Hello guys, welcome to the live stream. Today we will continue our fake news classifier problem. Let me give you a brief recap. So we imported necessary libraries, then we imported our CSV file. After that, you can say dropped all unwanted columns, and then in our you can say label column we have one label as fake and another label as real. We replace or you can say we map fake with 0 and real with 1, and then we head towards our text preprocessing part, in which we lowered the text. We splitted our text into words, then we removed stop words, and after that we performed lemmatization, and then again complete that you can say join that those words into a text, and then save this in you can say DF. Now you can say, and now we will convert words into vector. So first we will take use of that is a bag of words. You can say count vectorizer. Let me write here bag of words. Let me first import the libraries. So from scikit-learn root feature extraction, import. We have to import count vectorizer. Count. Oh, so it must be a dot text. Okay. Then import count vectorizer. So first we have to initiate this count vectorizer. I will give a variable name as BOW. That means bag of words is equal to count vectorizer. And here I will for you can say initial value, I will give n-gram range from 1, 1. So for you can say our first case, we will take just you can say just single word. Uh, Now let me transform, or you can say define my x is equal to bow dot fit transform underscore transform, and this had to transform on you can say df of text. Let's run this, and here you can see we can see our x. So it is sparse matrix. For you can say for visualization we have to convert this into to array, and then we can visualize this. Here you can see there is mostly all zeros, and somewhere it has you can say 1. Let me check its shape. Dot shape. Here you can see we have 6,335 rows and 58,031 columns. Let me do one thing. Now let me initiate. You can say dependent variable. Uh, so my dependent variable is equal to y is equal to df of label, and also let me check is my you can say my data set is balanced or not. here you can see we have 3171 for 1 and 3164 rows for 0, which is kind of, you can say, balance. So we do not need to perform any, you can say, balancing technique. Now what we will do, we will start, no, before that, before start training, we have to convert this into training and, you can say, testing set. Let me initialize here, splitting our data into training and testing set. So for that, first we have to import from scikit-learn dot model selection, import train test split. And then we will define xtrain, xtest, ytrain, ytest is equal to train test split, and then we will define our independent variable. This is capital X. Then after we will give our dependent variable, that is small y, and after it we will give our test size. So I want 80% as my training set and 20% as my testing set. So I will give value as 0.2. I will give random state is equal to, you can say, 21, and after that I will do stratify is equal to y. So it will split my training and testing data in same ratio as in, you can say, as it is in y. So here you can see this is 1 and 0 labels are, you can say, splitted in ratio 1 ratio 1. So if we let me run this command, and then I will show you. If you will do fytrain dot value counts, uh, here you can see for label 1 and 0, still there is a, you can say, ratio is 1 ratio 1. So now what we will do, now we heads towards training our model. Training our model. So first we will use multinomial naive novel naive. Let me import the library scikit-learn dot naive import multinomial nb, and then we will initialize it. Multinomial is equal to multinomial nb, and then we will train our model. So dot fit. So we will fit on, you can say, train and y train. Let's start fitting our model. Now what we will do, we will calculate accuracy score. Accuracy score. For that, we will use multinomial dot score. So now we have to give x test, comma y test. You can see we are getting around 0.89 as accuracy score, that is 89%. So let me create confusion matrix. Because we cannot evaluate our model using accuracy score, that our classification model is you can say performing good or you can say bad. So we have to for evaluating our model, we have to you can say find a precision and recall that we will that we can calculate using the confusion matrix and classification report. So first we have to import, you can say, scikit-learn dot uh, matrices matrix import. We have to import confusion matrix import, that is confusion matrix, comma, classification report. Now create a confusion matrix, that is CM is equal to confusion matrix. So we before that we have to you can say uh, predict y pred is equal to multinomial dot predict for x test. Then CM is equal to confusion matrix. Here first we have to give our you can say y true, that is y test, then y pred. So now what we can do, we can create a heat map using this confusion matrix. For that we will use SNS dot heat map, and then we will give this CM is equal data is CM, and then auto PLT, or let me check. So we have to give an annotation as true. Annotation is equal to true. Then PLT dot title as confusion matrix heat map, heat map PLT dot show. Let's run. Here you can see we get nice visualization. Now here you can see we are getting values like 5.4 e plus 0 0 2. So let's change its mechanism. Here you can see we are getting a nice visualization. Now we will create a classification report. Let me write in my term classification report. Now for classification report, we have to do classification report, and then we have to give value y test. Let me check. Yes, first we have to give y that is our y test, and then y pred. Let's run this. Here you can see our precision score for 0 is 0.93 and our recall score is 0.85, and for 1 our precision score is 0.86 and recall score is 0.94, which is nice. So using precision and recall we can find F1 score. So for 0 our F1 score is 0.89 and for 1 our F1 score is 0.90. So now we will what we will do we will you can say predict or you can say train this model for here you can see in Vago words we use 1 comma 1. Now we will do 1 comma 2, or you can say we will try to hypertune this bag of words. So here you can see we are getting around 0.89 and 0.90 as our F1 score. Let's try for 1 comma 2 and then try to you can say train our model. But accuracy score it will you can say give. Here you can see our F1 score is increased 0.91 and 0.92. Let's calculate it for 1 comma 3. Let's see our accuracy score will, or you can say F1 score will be increased or not. Let me check I am live or not. Here you can see we are live. Again we are getting the same F1 score, that is 0.91 and 0.92. Now let's you can say do it for 2 comma 3 instead of 1 comma 3. uh, Here you let's see here you can see we are getting F1 score as 0.93 and 0.9341, which is very nice. Let's do it for 3 comma 3, and then we will do it for 2 comma 2. You can see our F1 score is decreased. Let's do it for 2 comma 2. You can see F1 score is 0.91, 0.92. Let's you can say continue with our 2 comma 3, because using 2 comma 3 uh, we are getting around, you can say, 0.93 as F1 score. Let's see. Here you can see our reference score is 0.93. So now what we will do, we will train our let's try with, you can say, using TF-IDF factorizer. So next method is TF-IDF. Right there. Now we will check using TF-IDF what will be our, you can say, accuracy score. It will increase or not from scikit-learn dot feature extraction dot text. Let me import TF-IDF vectorizer. We will initialize as TF-IDF is equal to TF-IDF vectorizer, and similarly we will start using n-gram range as 1 comma 1, and then after this we will hypertune x is equal to TF-IDF dot fit underscore transform. Also we have to give df of text. Here you can see we are getting around 0.8140, 0.8641 as F1 score. Let's do it for 1 comma 2. Here you can see what's my you can see column size. It's very huge. You can see our reference code is decreasing. Let's do it for 1 comma 3. I think it will decrease. Let's see. So we are getting 79 and 85. Let's do it for 2 comma 3. Let's see how much score we will get. So we are getting around 89 and 91. Okay, let's do it for 2 comma 2. I think we will get maximum, you can say, a maximum score using count factorizer, and n range will be 2 comma 3. You can see our reference score is 88 and 90. Now let's do it for 3 comma 3. Here you can see we are getting around 0.90 and 0.89. Let me give this converting to, you can say, comment and write it here. We are getting a maximum score using count vector riser and p with hyper tuning as n gram range is equal to 2 comma 3. Okay. So now we will, you can say, hypertune. Let me run this again. Now we are calculating using, you can say, multinomial naive algorithm. Now we will do it for logistic regression. Here, logistic regression. This is our model number 2. Now, let me import logistic from scikit-learn dot linear model import logistic regression. We can also use logistic regression CV, so it will, you can say, do cross validation, and it automatically hypertune our, you can say, algorithm for our you can say best score. So we will use logistic regression CV. Now let me do reg is equal to logistic regression CV reg dot fit. You will fit x train and x train y train. Let's start. So it will be here. Oh, so instead of comma we have to use dot. After fitting our model, then we have to find the, you can say, score. Here. Then we will create confusion matrix. So instead of multinomial, we will use reg for predicting y-pred. Then we will create confusion classification report. Classification report. Let's see how much time it will take. Or we can do, let's copy this cell. Now, instead of this logistic regression, what we will do, we'll do it for, you can say, random forest classifier. From scikit-learn dot ensemble. We have to import random forest classifier, and then instead of reg, we will paste forest. By the way, I read somewhere that for NLP problems, multinomial that multinomial naive Bayes model is best for you can say training. but we will, you can say, train using different models and check from which model we will get maximum accuracy. Instead of red, it is forest this time. It is forest. And we can, you can say, we can also predict it for SVC using SVC, or we can predict using boosting technique. Let's see, is there any comment or not? So there is, here you can see it is taking around 9.4 GB of RAM. Let me check X train. Just X. Here you can see shape of X. Either it is around 38,000 or no, it is not 38,000. It is 3 lakh 83. No, it is 38 lakhs and 35,000 columns. Oh my god. That's why it is taking so much time for training. Now we will change this for SVC algorithm. Also, you can see multinomial algorithm trained so much fast as compared to this logistic regression. From scikit-learn dot, you can say SVM. We have to import SVC. SVC. scikit-learn dot SVM. So we have SVC. Okay. Now will be for our fifth model. We will train or you can say we will train it on you can say on boosting algorithms. Like, I think XG boost will be best. So we will take XG boost. It is still running. Let's see how much time it will take. I guess it is an escalate boosting. Let's see. XG boosting scikit-learn. So it is in ensemble. Ensemble import gradient boosting classifier. give a gradient posting. Let's give this grade. Now let's run all these cells, and then from you can say best suited model, we will hypertune that model. Let's see how much time it will take. Or we can do for this moment, let's restart our kernel and train for you can say for a random forest classifier algorithm. Uh, Offline, I will try it for you can say logistic regression. Let me give this in comment form. Also this in comment. Okay, okay, okay. So we get our model trend, which is nice. So we turn it to comment this one. So here you can see we are getting our FN score as 0.92 and 0.92. So here multinomial is performing better. Let's compare with all other algorithm also. Let's see how much time it will take now. So logistic regression took. Oh, I'm really sorry. I think that took around 1000 seconds. 1000 seconds. So that take around 16 minutes. Let's see how much time this random forest classifier will take. Also, let's check for you can say count factorizer. There is any you can say uh, a random state variable. Here we can see this is giving us 0.90 and 0.89 Apple score. Again, here also multinomial is performing better. So let me give here. And let's check. Here you can see till then, what we can do, we can start preparing for our, you can say, saving our model. And import vehicle with open. Then we have to give our, you can say, model.pkl wp as f. Then we have to do pickle dot dump. Then we have to give our, you can say, model name or multinomial. It is multinomial. Multinomial comma f. Also, we have to save our scalar also, or you can say vectorizer with open vectorizer dot pkl as f pickle dot dump bag of word comma f. And also check my multinomial hyperparameters. And it is smoothing parameter false alpha. If false and alpha is less, then it will settle. If true, if I change this will cause numeric error. Fit whether to learn class prep. I think for this we do not need hyperparameter tuning. So we will you can save this vectorizer as it is. Let's see what score we will get for using gradient boosting technique. I think it will take a lot more time as compared to linear regression. Oh, I'm sorry, logistic regression. Let me check. Oh, hey, I wrote okay, logistic regression. I thought by mistake I wrote, you can say, a linear regression. Till then, we can do one more thing. We can start working on, you can say, web part. Let's work on this project. Let me copy this and paste it here. Fake news classifier. So let's start working on our Flask web part. So first we have to import Flask, yes. Then we have to import numpy request pickle re, yes. Then instead of this, uh, we have to import from scikit-learn dot count. Okay, we do not need to import this also. I will define it here. Vectorizer is equal to pickle dot load open vectorizer dot pkl rb. Then we have to edit this, you can say, vectorize function. Instead of review, we have to write text. okay, just put it true. And one more thing. Let me copy this part also. And not to import these libraries also. Let's see. It's still in training phase. Let me check. For our zero, it is for fake. For zero, it is fake, and else it is real. Let me give this real, 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 fake, fake, and fake. Now we have to just edit our vectorize function. Okay. Now let me delete this prediction.html and create true and false.html. You can see. Now in index.html, fake news classifier, fake news classifier. Here we give this as text. Or we give this as news, and here I will give this as news. So we are done with, you can say, index.html, it is still. Now let's change to, instead of false.html, it is fake.html. And let me rename this also, real.html. It is fake news class C fire. Fake news class C fire. And this is for real.html. This is a real news. And then let's do it for fake. Fake news class C fire. Fake news class C fire. This is a fake news. Also, let me do one more thing. How can I put, let me, it is in Starbucks. Or we can do one more thing. Here we will give value as, you can say, this is for fake, this is a fake news. And instead, now copy this code. Okay, instead of green, we will use red. And same, we will do it for, you can say, real.html. And for this, we will use green. Let's see. It is still in training phase. Let's try to run here to test him. Here you can see. You can see this is a fake news. And let me check our index. Here you can see. Let me do one more thing. Inside fake, let me capitalize this fake F. And in real, let me capital this R. Now we will work on our vectorize function. Now let's do vectorize the dot transform. You can say text dot ratio. I think we do not need this. Let's see. So here we have created our web app, and we are calculating for you can say gradient posting classifier. What will be the you can say F1 score, and then we will save our model using pickle. So I guess this is enough for today. Uh, 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 I will you can say it will keep running, and when it will you can say give me the results, uh, I will you can say write it here, and then I will save what you can say, or you can say we will hypertune our multinomial model on tomorrow's session. Thanks for watching.